I'm Rebecca Eunice, a semantic web developer at Cornell University Library, working on linked data for libraries labs, a project funded by the Andrew W. Mellon Foundation. This video introduces you to VitroLib's ontology browsing capabilities. It does not cover the more advanced topics of adding and editing ontologies. This VitroLib instance has been preloaded with RDF data for 29 sample records from the Cornell University Library catalog. Since I'm already logged in, I'll navigate to the site admin page using the link in the upper right-hand corner of the screen. The site admin page displays only the links that you're allowed to access based on your role. In order to browse the ontology, you must be a user with the curator or site admin role. If you don't have one of those roles, you won't be shown the set of links under the section Ontology Editor. Here, I've logged in with a site admin account, so I have access to the ontology data, plus a number of other areas that are limited to site admin accounts. This version of VitroLib comes with several pre-installed ontologies and ontology fragments. These were defined during the LD4L 2014 to 2016 project. The VitroLib version used in the LD4P project will instead be based on the target ontology and ontology fragments defined by the LD4L Labs LD4P ontology group, once these have been fully specified. Let's look first at the list of the preloaded ontologies. For each ontology, the ontology list displays its human-readable name, its namespace, and optionally a prefix that can be used when referencing its terms, such as in Sparkle queries. Because an ontology appears in this list does not guarantee that any or all of its terms have been loaded into the instance. These are added elsewhere, either manually or through configuration files. Going back to the site admin page, let's now explore the class hierarchy. This view lays out the class hierarchy from the top-level classes on down. For each class, it shows us the ontology that defines it and any subclasses it has. It also shows its class group membership. That's a concept we'll discuss later. Here, we see that FOF agent has 3 direct subclasses, and also that one of these, FOF organization, itself has a subclass. I can click on the plus sign to the left of FOF organization to get more detailed information, the class group and ontology it belongs to, and its subclasses, if any. And I can click on the minus sign to close this back up. I can get even more details about a class by clicking on the class name itself. Let's look at FOF person. Here we can see a variety of details about this class, including its label, the ontology that defines it, its local name, its full URI, and some application level features, such as display rank and visibility. Scrolling down the page, we can see additional information, such as its superclass. If it had any subclasses, we would see those here as well. We can also view a list of individuals in the VitroLib instance that belong to this class by clicking on the Show All Individuals in this class button. Here we see a list of all FOF persons in the system. Scrolling down to the bottom, we see that there are 95 persons. We can also see only those individuals that are asserted as opposed to inferred to be in this class by clicking on the Show Individuals Asserted to be in this class button. In the case of persons in our current system, we also have 95. The two lists are the same. To clarify this distinction, let's look at details of the agent class, which is the superclass of the person class. I can get directly to the agent class by clicking on the superclass link. Because the agent class has subclasses, that list displays further down on the page. Because person, for example, is a subclass of agent, this means that any person is also an agent. When we look at all the individuals in the agent class, we see a long list of 148 agents, which includes both individuals directly asserted to be agents as well as those inferred to be agents through subclass inferencing. If we now look at only individuals asserted to be agents, we see only 3. The other 145 agents have been inferred to be agents because they belong to one of the subclasses: person, family, or organization. I'm ignoring the links on the right side of this page since they're used for various kinds of class editing, which we're not covering in this video. Returning to the site admin page, we also see an item called class groups that I've already mentioned in passing. By clicking on this link, we again see all the ontology classes, but this time grouped by class group membership. At the top, for example, we see the works class group with a list of all the classes that have been assigned to this group. It's not necessary for a subclass to be in the same group as its superclass. For example, the agents class group has been defined to include only the agent and family classes, not the other subclasses of agent. These are included in different subclass groups: the person class in the people class group, and the organization classes in the organizations class group. The reason for this is that the class groups are not defined in the ontologies and do not represent any semantic structure, but rather are application-level constructs that control some of the behavior of the application, such as display. For example, the index page displays a list of all the instantiated classes and how many individuals of each class there are, with the classes organized by class group. So here again are the people, organizations, and agents class groups with the classes listed underneath. Due to the primary importance of persons and organizations in the network of bibliographic data, it seemed useful to pull them out into their own class groups rather than including them in the agents class group, so that they'd be featured more prominently in the display. But this is merely a configuration decision that's not based on the ontology per se and can be modified easily. As another example, if we go back to the site admin page, we see at the top the form used to create a new individual. There's a drop-down to select the class of the new individual. Here the classes are also organized by class group. For example, the various work classes are listed under the works class group, instance classes under the instances class group, and so on. One important thing to mention is that classes are not displayed in certain contexts unless they belong to a class group. For example, if a class doesn't belong to a class group, it doesn't appear in this drop-down, so it's not easy to add a new individual of that class. Sometimes that's what you want. For example, the annotation class has not been assigned to any class group and does not appear in the drop-down because annotations would not be created independently through this form, but only in relation to the resource that they annotate. In the next section of links, we can view the object and data type property hierarchies. This looks very similar to the class hierarchy, where we see the top-level properties listed with any sub-properties. Each property is shown with some basic information: its local name, the property group it belongs to, and its domain and range if specified. I'll get back to property groups in a few moments. The accompanied by property has 3 sub-properties, and by clicking on the plus sign next to one of them, we can again see the local name, the property group, and domain and range. This property doesn't belong to a property group, but it does have both domain and range specified as work. We can click on the name of a property to drill down into more detailed information about the property. Let's look at the has title property in more detail. Here again, we see the ontology that defines the property, its local name and public display label, any defined domain and range classes, whether it's transitive, symmetric, functional, inverse functional, etc., and toward the bottom, some application-level features such as display rank and visibility, and the full URI. By scrolling down, we can see that this property has a subproperty, has preferred title. We can also see sample assertions using this property by clicking on the Show Examples of Statements using this property button. Here we see a list of assertions, including subject, the type of the subject, the property itself, the object, and the type of the object. Let's also look at the hasInstance property. To verify that the inverse property isInstance_of has been defined as we saw in the previous video on editing instance data. We scroll down to go to the Go to Inverse Property button. And in fact, here we do see the definition of isInstance_of. The data property hierarchy works just like the object property one, aside from the inherent differences between object and data type properties. So I'll leave that for you to explore on your own. One more feature to note is the property groups. Like class groups, these are not part of any of the ontologies per se, but are application-level constructs that group properties for display purposes. For example, the properties name, birth date, and death date are assigned to the identity property group. If we navigate to the profile of a person, we see that the properties are organized into tabs, where each tab represents a property group. So we have property groups identity, works, and awards. And going to the identity tab, the name, birth date, and death date are all displayed on that tab. This provides a logical organization of the data to facilitate browsing. Properties that don't belong to any property group are displayed under Other. This concludes our overview of ontology browsing in VitroLib.